Alright, this should be the last video in terms of the types of polynomials we have to deal with. What happens if your cubic has 4 terms? How does this even happen? Well, let's look here for a moment. I pre-wrote a problem for us to look at. There you go. I blocked out the back part and I realized it said pre-wrote. Writ beforehand. Anyway, if you FOIL this out, you'll see that you end up with 4 different terms, and these 2 center terms can't be combined because they aren't like each other. They aren't like terms. That's what happens when you have, that's how you have created a polynomial that has 4 different terms. So when we unwind this, when we take it apart, we'll actually have to create a set of binomials similar to this, where you have x squared or like not similar powers on the x. We're used to creating x and x, but it says x squared and a value and then x and a value. How are we going to do this? Here are some steps. First, make sure that the order of the terms is in descending power. That simply means 3, 2, 1, none. Then what we're going to do is we're going to group the first 2 in parenthesis and then group the second 2 in parenthesis. What that means is we're going to use parenthesis around these 2. We're going to use parenthesis around these 2 here. All right, I'm not going to capture this because I want it to be not a multiplication problem. Then what we're going to do is to GCF both groups. I'm going to find the common factor, greatest common factor of this one, and the greatest common factor of this one. Lastly, I'm going to group the 2 GCFs in a single parenthesis and write the matching binomial from step 3. What does this mean? Let's look and see what we're talking about. All right? All right, oops, my bad. Here we are. All right, I just kind of abbreviated the list of rules here for a second. So first one, we just order the terms. Now these are already in descending power, 3, 2, 1, none. What I'm then going to do is to group the first 2, grouping these 2 as together and then grouping these 2 as together. All right, that's step 3. I'm going to GCF both groups. Now I'm going to pull out different things. Looking only here, I see I have 2x cubed and 6x squared, and I need to divide both by the most that I am able to. So in red working, I erased part of my groupage there. If I were to divide this and this both by the value of 2 and by x squared, what I would arrive with would be 2x squared out front. This would leave just x, and this would leave a positive 3. All right, so then what I'm going to do using purple, I'm going to take the GCF out of this. This looks to be just 5, right? So I'm going to use a positive 5, and I'm going to write the remainder, which will be x plus 3. Notice that I have 2 different GCFs. I have a GCF here, and I have a GCF here. Notice also, and this is really, really important, it's the point of this, this is identical to that. The 2 binomials are identical. Step 4 is to group up the 2 GCFs. So I'm going to take my 2 GCFs and put them in one package. So here they are, 2x squared plus 5. These are my 2 GCFs. And I'm going to take this single binomial that matches and simply record it or write it here. And we are finished. All right. I had my calculator up. I just popped it up. We should check. So as always, we could multiply that by hand. Another way, as always, would be to use the y equals. I've already typed in my original into the first line. So I'm going to check and make sure. Now remember, my original had no parentheses to begin with, so it was simply, oops, so it was simply the 2x cubed plus 6x squared plus 5x plus 15. That's what I've typed into the calculator. 15. That's here. And then down in this line, I have my final response. So if I were to check the table second graph, I would see that my y1s match my y2s, a strong indication that I've done it correctly. And that's pretty much the process, and we'll just do that again and again. I do remind you always that we should look for GCFs whenever we are able to in all of these processes. All right? Here's a brief set of steps. Descending power, make groups, GCF the groups, rewrite. All right? So, I'm looking for a GCF. I do not see one. What I'm going to do is I'm going to make sure it's in descending power, then I'm going to group it here. Let me make this a little bit larger so I can write it more easily. Grouping these two, and I'm actually going to go ahead and group these this way because I want to catch this negative. So here I'm going to GCF. It looks like I have an A. In fact, it looks like I have an A squared. So this one's going to be written as A squared multiplied to A plus 7. Now, notice that all of the signs inside of this first binomial are going to be positive. All of the signs here are negative. What I can do, I can divide this second one by a negative value, a -3. If I do that, I will leave a positive value here and a positive value here, and I will have this, -3 parenthesis A plus 7. I did this so that this phrase here is identical to this phrase here. I'm going to rewrite, and part of this is going to be to group GCFs in one parenthesis. So I'm going to take ESIS. I misspelled that. ESIS. I'm going to take my two GCFs, my A squared minus the 3. Box them. Notice that these are identical again. I'm going to just write it here as A plus 7, and we are finished. All right? We should check ourselves. So if I'm going to check this, I could do A squared minus 3. This is a check, by the way. Multiplied to A plus 7. This distribution will give me A cubed. This distribution will give me a positive 7A squared. Underneath will give me a -3A. Here will give me a -21. I'm going to look to see if I can combine any like terms, but they are not like terms, so I can't combine them. This is identical to what I started off with, which means that I am correct. All right? This next one, same story. Make it a little bit larger so we can write in between the parts. What I want to do is to box these first two. Make sure it's in descending order, please. And again, you see how these are both negatives? That's a big indication that I want to go ahead and catch the negatives, and I will factor out a greatest common factor, which will be negative. Greatest common factor here and here will be x, and in fact I have two of them. So this GCF is going to be x squared. Inside the parenthesis will be left 2x plus 1. Notice that x squared divided by x squared is 1. This is one of my GCFs. On the other side, I'm going to use a negative value. Looks like negative 9. So my GCF is going to be negative 9. Inside, divide this, I will have negative 2x, and I will have positive, I'm sorry, I did that, it didn't mean negative 2x, it meant positive 2x, positive 1. Alright, so now, again, notice this is identical to this. That's what we want. So I'm going to rewrite and group my GCFs here, and I'm going to have 2x plus 1. Now, as always, we should pay attention. This is in fact a difference of squares here. Depending on the directions, we should factor completely. So I'm going to go ahead and write factor completely. Which means I can't leave this way. So recall, if you will, that a squared minus b squared can factor as a plus b and a minus b. So we have x times x, and we have 3 times 3. This is going to come apart into two different pieces, two different factors, I should say, as x plus the 3 and x minus the 3, bringing down this last factor to be 2x plus 1, and in fact we are now completely factored. That's the process. Practice these, ask questions. Thanks.